All right, so in the last unit, we looked at log functions. We saw that they were the inverses of exponentials. We looked at the definition of a log, switched back and forth between log and exponential form, and did some graphing. So now we're going to look at some properties of these logs. Now, I want to remind you first of some different rules that we have with exponents. Okay, these are all things that you've seen in the past. So first, recall that whenever you multiply two things together, as long as they have the same base, then all you do to simplify is you just add your exponents. We also know that if you divide two numbers with the same base, then in order to simplify, you subtract your exponents. And then lastly, if we have something with one exponent raised to another, then we multiply our exponents. Okay? Well, logs really are just exponents. So for every exponent property, we have an equivalent log property. So here, with our product rule, we saw when we multiply, we add the exponents. Well, similarly, if you have a log of a product, so when you're multiplying, it's equivalent to adding the logs. Okay, so our product rule tells us that if we have the log of a product, then we can split it up as the sum of two logs. Okay. All right, well, then if we think about our quotient rule, it's the same kind of relationship. When we divided, we subtracted our exponents. So over here, when we divide inside the log, you divide the argument of the log, then it turns into subtraction of logs. And then product rule, we saw that one power raised to another, we multiplied. Well, product rule for logs says that if we have a power in here, so something like x raised to the power of y, then we multiply that power by our log. Okay, so these three properties, the product rule, the quotient rule, the power rule, are what we're going to be focusing on in this section. So the first thing we're going to do is we're going to use these properties to expand logs. We're looking at expanding logs. Okay, and by expanding, I mean we're going from the left to the right. So we're going from a product to a sum, from a quotient to a difference, from one power raised to another to this multiplication. Okay, so we're making our logs bigger. All right, so let's do some examples. Let's say first we have the log of, oh, I should probably tell you what we're doing. So we're going to expand and simplify. Okay. All right, so let's start with the log of 5x. Okay, so in here, the 5 times the x, that is a product. Okay, so whenever we have a product, we can split it up as a sum. So this would turn into the log of 5 plus the log of x. Okay, so we're changing our product into a sum of logs. All right. So similarly, if we had the log of 7y, again, it's a product, so we would split it as the log of 7 plus the log of y. All right, how about the log base 5 of 25x? Okay. All right, again, a product. So we would turn this into the log base 5 of 25 plus the log base 5 of x. Now here, there's a little bit of simplifying that we can do. So if you look at our log base 5 of 25, remember when you're evaluating a log, you're thinking to yourself, 5 raised to what power would give us a 25? And since 25 is a power of 5, we can simplify this. So 5 raised to the power of 2 equals 25, which means that's just equal to 2. And then we'd still have plus the log base 5 of x. So as you're expanding, you also need to make sure you're simplifying, okay? We didn't do anything up here with the log of 5 because 5 is not a power of our base of 10, so there was nothing more we could do to simplify it. But on this part C, 25 is a power of our base, so we're able to simplify that down. All right, let's try the log base 6 of 6xy. Okay. All right, here we have a product of 3 different terms, so we're just going to split this up as 3 different logs. So this would become the log base 6 of 6 plus the log base 6 of x plus the log base 6 of y. Now again, we can simplify this first one because 6 raised to the power of 1 is equal to 6. That first term is just 1. And then we still have plus the log base 6 of x plus the log base 6 of y. All right, let's do a couple more. Say we have the natural log of 6x. Okay. Again, a product. So we're going to split this as the natural log of 6 plus the natural log of x. Okay. All right, now here, remember our natural log has a base of e, so 6 is not a nice power of e, but 6 can still be broken up further. Okay, 6 is not a prime number, which means we can split it. So I'm going to think of my 6 splitting it up as a product, factoring it. That can turn into 2 times 3. Okay, splitting up that 6 into its factors. Well, now, once you split it up as a product of 2 times 3, we can use the product rule on that again. So this becomes the natural log of 2 plus the natural log of 3 plus the natural log of x. Okay, so as we're expanding these, you have to think about not only splitting up the obvious products like the 6 times the x, but also looking for things that are a little less obvious, looking for numbers that are not primes. And if you can't just simplify like we did in the previous example, right, the log base 6 of 6, that we were able to just simplify as a 1. So we didn't have to worry about factoring it any further. But the natural log of 6, it couldn't be simplified using our just definition of a log. So instead we thought, okay, what we can do with it though is factor the 6 because it's not a prime number, and then break that apart a little bit further with our product rule. So look for things that can be broken up as far as you can go with them. All right, let's do one more with this product rule, and then we'll move on to our quotient rule. All right, so let's say we have the log of 20y. Okay, so again, we have a product of the 20 and the y. So I'm going to split that as the log of 20 plus the log of y. Okay. All right, remember a log without a base has an understood base of 10. Okay. Now again, 20 is not a power of 10. So we can't simplify this just yet, but what we can do is keep expanding it further. Because 20 we can think of as the product of 10 times 2. All right, and now that we've thought of it as a product, we can split it up again using our product rule, and that would become the log of 10 plus the log of 2 plus the log of y. Okay. Well, now we can simplify this first term because again, remember that our understood base on this is a 10. So I know that 10 raised to the power of 1 is equal to 10. So this first term is just 1. 2 is a prime, and 2 is not a power of 10, so there's nothing more we can do to break that one down. So that's just log of 2. And then, of course, we also just still have our log of y on the end. Okay, so look for numbers that can be factored and look for logs that can be simplified as you expand these with your different properties. All right, guys, I'm going to end this video here. We're going to do several videos for these properties of logs, so keep watching for the quotient rule and the power rule.